You know that moment, right? Your analytics dashboard is just spinning
Mm-hmm.
and spinning.
Mm-hmm.
And those crucial business decisions, they're just stuck waiting.
Yeah, it's incredibly frustrating. That slowness, getting insights way too late.
Exactly. And that's what we're really digging into today. How to speed up your cloud analytics.
And it's interesting because, often the bottleneck isn't just needing more raw computing power.
Yep.
It's not always the servers.
Right.
The real gains, surprisingly often, come from something more fundamental, the way your data is actually structured, how it's laid out in your cloud object storage, your S3, ADLS, GCS.
So the architecture, the foundation of the data itself.
Precisely. It's just as vital as the fancy engines you might be using to analyze it, maybe even more so sometimes.
Absolutely.
Yeah.
And we're not necessarily talking about needing the absolute latest tools or throwing more engineers at the problem.
No, not always.
Sometimes the biggest performance improvements, those real leaps, come from optimizing that data layout. So if you're dealing with large data sets, maybe feeling that pain of sluggish queries or watching your cloud costs just creep up.
Which happens a lot.
Yeah, then this deep dive is definitely for you. Our mission today is really to pull out the essential strategies, the key things you need to know about optimizing cloud data layout for, well, significantly faster analytics.
Okay, so where should we start? How do we begin to unpack this?
Well, the first thing that really jumped out, and it seems foundational, is the choice of file format. How the data is actually saved.
Yes, exactly. For analytical workloads, which is what we're focusing on, columnar formats are generally much more efficient. Think Apache Parquet or ORC.
Okay, columnar. What's the key difference compared to, say, the CSVs or JSON files people often start with?
Right. So the big difference is how they organize the data. In a traditional row-based format like CSV, all the information for one record, say, one customer transaction is stored together, then the next record, then the next.
Okay, so like a spreadsheet row,
Yeah.
customer name, city, purchase date, all in one line.
Exactly. But with a columnar format, it flips that. All the customer names are stored together in one block, all the cities are in another block, all the purchase dates in yet another.
Ah, okay.
Now here's the payoff. Imagine you only need to analyze purchase dates to spot trends over time.
Right, a common query.
With a columnar format like Parquet, the query engine only needs to read that specific block of purchase date data. It can completely ignore the customer names and cities.
I see. It's like needing just the flour for a cake recipe. You don't have to pull out every single ingredient from the pantry. You just grab the flour bag.
That's a great analogy. It drastically reduces the amount of data that needs to be read from storage, scanned, and processed.
Which means faster queries.
Much faster queries. And, critically, lower compute costs. Because you're doing less work. You're not wasting cycles reading data you don't even need for that specific analysis.
Makes sense. So while row-based formats might be fine for, say, transactional systems where you do need the whole record at once,
Correct. They have their place.
for these big analytical queries, they become a real performance drag.
A major drag. Plus, another benefit, columnar formats often achieve much better data compression because data within a single column tends to be more similar and thus more compressible.
So smaller storage footprint too.
Yeah.
Lower storage costs.
Yep. Less data to read, less data to store. It's really efficient for analytics.
Okay, so for big data analytics, switching to something like Parquet or ORC sounds like, well, almost a must-do.
It often provides one of the biggest initial bangs for your buck, yeah.
Now, you also mentioned partitioning is key. What's the idea behind that?
Right, partitioning, think of it as strategically dividing your massive data set into smaller, more manageable chunks or segments, and you divide it based on specific criteria, specific columns in your data.
Okay, breaking it down, like how?
A really common and effective strategy is partitioning by date. So instead of having one giant monolithic bucket with, say, all your website traffic data from the beginning of time.
Which could be enormous.
Exactly. You'd organize it. Maybe you have separate folders, essentially, for each year. And then within each year folder, maybe subfolders for each month or even each day.
Okay, I can picture that structure. Year, then month, then day. So how does that help the query speed?
This is where the magic of partition pruning comes in. Let's say you run a query and you only care about website visits from yesterday.
Yeah.
If your data is partitioned by date and your query includes a filter like where date yesterday, the query engine is smart enough to know it only needs to look inside the partition folder for yesterday.
Ah, so it doesn't even bother scanning the data from last week, last month, last year.
Exactly. It completely skips or prunes all those other partitions that don't match your date filter. It's like a librarian knowing instantly which shelf holds the book you need instead of wandering through the entire library.
Okay, that's another huge efficiency gain. It just ignores irrelevant data wholesale.
Dramatically reduces the data scanned, which again means faster queries and lower costs because you're scanning less data from S3 or ADLS or GCS. It leverages the metadata about what's in each partition.
That's brilliant. Simple, but really effective. So besides date, what are other common ways people partition data?
Date is super common, as we said, but geographical region is another popular one, especially if you often filter by country or state, product category, customer segment. Basically, you want to partition by columns that you frequently use in the where clause of your queries.
The things you filter on most often.
Yes, but there's a crucial warning here. Avoid partitioning by columns with very high cardinality.
High cardinality, meaning columns with lots of unique values.
Exactly. Like, don't partition by individual usered or transactioned. If you do that, you'll end up with millions or billions of tiny little partition folders.
And that's bad.
Yes, that creates a different kind of problem. Managing all that metadata becomes overhead, and reading lots of tiny files can actually be slower than reading fewer larger files. It kills performance.
Right, okay, so there's a sweet spot for partition size.
There is. A general guideline is to aim for partition sizes somewhere between, say, 128 megabytes and 1 gigabyte. You want them large enough to be efficient for the processing engines to read, but small enough that pruning is effective. It's not exact science. It depends a bit on your specific queries and tools, but that's a good starting range.
So the Goldilocks principle for partitions, not too big, not too small.
Pretty much, yeah.
Can you give us a quick real-world example? How does this actually play out for a company?
Absolutely. Let's take a retail company. Imagine they have a data lakehouse, maybe running on S3. Initially, they just dumped all their sales transaction data in as CSV files. No partitioning.
Okay, the default starting point for many.
Right. And their analysts complained dashboards were slow, ad hoc queries took ages, and the cloud bill for scanning all that data was climbing.
Sounds familiar.
So the data engineering team did two main things. First, they converted the data from CSV to Parquet, getting those columnar benefits.
Step one.
Step two, they started partitioning the data. They chose two keys: transaction date and the geographic region of the store.
Okay, based on common query patterns.
Exactly. And the results were pretty dramatic. They saw something like a 70% reduction in the average amount of data scanned per query. 70%.
Wow, that's huge.
It really is. And that translated directly into significant cost savings on their monthly cloud bill. But just as importantly, their analytics dashboards became much more responsive.
So analysts were happier, presumably.
Much happier. Business users could get insights faster, make quicker decisions, and the engineering team. They spent way less time troubleshooting slow queries and performance bottlenecks. It was a win all around.
That really paints a clear picture. So the takeaway seems clear. If your analytics are feeling sluggish, or if you're seeing those cloud data warehousing or lakehouse costs going up and up,
Yeah.
it sounds like one of the very first places you should look is your data layout strategy. Are you using the right format? Are you partitioning effectively?
And that really brings us to a crucial question for you, the listener. If you are experiencing slow analytics, if those costs are rising, maybe it's time to seriously rethink how your data is laid out in the cloud. Could that be the key?
A really important question to ask. And if you want to dive even deeper into the nitty-gritty file format comparisons, more on partitioning best practices, maybe even things like sorting within files, we definitely recommend checking out the full blog post this deep dive is based on. It's called Faster Analytics Queries. How should engineers optimize data layout in S3 ADLS GCS? We'll put a link in the description.
Yeah, it goes into more detail on some of these points.
And of course, for more insights like this, helping you move from, let's say, messy data to measurable results, make sure you follow Curate Partners.
Ultimately, it really comes down to being intentional, being strategic about how you structure your data. It's not just about dumping it somewhere, it's about organizing it for efficient access.
So let's recap the big ideas. Choose the right file format for the job. Lean heavily towards columnar formats like Parquet or ORC for analytical workloads. And implement a smart partitioning strategy, usually based on date or other columns you filter on frequently, keeping those partition sizes in that optimal range.
Structure
And
secure.
query fast.